Hello students, in today's class we shall discuss about the properties of matter and their measurements. So let us see what are the properties first. Properties of matter. So matter has mainly two types of properties. They are called as the physical properties and chemical properties. So let us see here two types of properties: physical properties. Second one is chemical properties. So what is the main difference between these type of the properties? Physical properties means it involves only physical change. And no chemical change is observed. So in these properties means any property that includes change of only physical state but not the chemical formula or chemical composition, such type of properties are called as the physical properties. Let us take examples of these physical properties. These may be color, odor, melting, boiling, sublimation, etc. So let us discuss about these, how these are called as the physical properties by taking one example. We know the ice. Ice is in the solid state. Its molecular formula is H2O. And when you heat it above 0 degrees centigrade, it converts into the water. Water is in the liquid state. Again, molecular formula is water is also H2O. And again, when water is heated above 100 degrees centigrade, it converts into the vapor, water vapor. It is in the gaseous state, but even water vapor molecular formula is also H2O. Means here, there is only change of physical state, solid to liquid, liquid to gas. Physical change is observed, but a chemical formula is not changed. That's why these properties are called as the physical properties. And this process, here the property, what is this property? This property is called the melting. And this property is called as the boiling. Let us take another example where iodine exists in the solid state. When you heat, this iodine directly converts into the gaseous state. So conversion of any substance from solid state to the directly into its gaseous state, that property is called the sublimation. So during the sublimation of iodine, there is no change in the chemical formula of the iodine, but only physical state is observed. Like that, you can take the camphor also. In the solid state, if you heat, this camphor also directly converts into the camphor in gaseous state. This process is also called the sublimation process. Here iodine vapor's color is violet. So here color change and physical change both are observed. So all these properties which involves only change of the physical state but not the chemical formula are called the physical properties. Now let us discuss about the chemical properties. Chemical properties includes chemical change, means chemical formula change is observed. And what about the physical change? Physical change may or may not be observed. So let us take one example here. HCl is an acid. Take its liquid and NaOH. You take in the aqueous form. This is called as the base. when HCl reacts with NaOH, completely it changes to the NaCl, which is in the aqueous form, and water is formed. So in this particular chemical reaction, what we have taken HCl and NaOH does not exist after the reaction. Means there is completely change of the chemical formula is observed. At the same time, both are in the almost the liquid form and physical state is not observed in this case. So for chemical properties, change of chemical formula is observed and physical state may or may not be observed. So these are about the some introduction part of the properties of the matter. Now let us discuss about the measurements. So let's discuss about the measurement now. The definition of measurement is any quantitative observation represented by a number followed by a unit in which it is observed is called measurement. So let's have this small discussion about this definition. Any quantitative observation represented by a number. Let us imagine the length of a room is 10 meters. So 10 meters is the observation I did and I measured also. Can we call this one as a measurement? Yes, we can call this one as a measurement. Why? Because there is a quantity. Quantity is involved and moreover there is a number followed by unit. So number followed by unit is always called as the measurement. Simply if we say the length of the room is only 10, it is not called as the measurement because it is not including any type of the unit, so that automatically we get the doubt whether it is meters, kilometers or centimeters. And if we say only m without saying any number, then also we get the doubt how many meters the length of the room is having. That's why a measurement must include number followed by a unit. That is called as the measurement. Now, how many types of measurements are there? Actually, measurements are of two categories. So it is English system. Second one is metric system. So metric system is widely followed. Let us see internationally accepted system, SI system. So in SI system, basically 7 fundamental units are there. So these are called the base units. Let us see those base units. Serial number, physical quantity and its symbol. Unit and unit symbol. So first one is mass. Mass symbol is m, but its SI unit is kilogram. Kilogram symbol is kg. Second one is length, L, and its unit is meter. Its symbol is small m. Third one is time, small t, and its unit is second, and its symbol is S. Temperature, capital T, Its unit is Kelvin. Kelvin symbol is K. 5. Amount of substance. So this amount of substance usually we represent with the symbol small n. And the unit of this amount of substance is mole, and the symbol is also mole. Only E is not present in the symbol. 6. Electric current. I is the symbol of the physical quantity, but its unit is ampere. Unit symbol is capital A. 7. Luminous intensity. IV. So it is candela. CD. So basically 7 base units are present. Whatever the other units we are deriving, they're all derived from these units only. Hence those units are called the derived units. Let us see some of the derived units now. For example, area. Area means length square. That means if you use the meters, it will be meter square. So meter is the base unit of the length. And volume. Volume means length cube. That means meter cube. Again, meter is taken from the base units. Similarly, velocity. Meters per second. Meter and second, both are in this base units only. Next, density. So density means mass upon volume. So mass units are kg, volume units are meter cube. Kg and meter cube again present in the same base units. So whatever the other units derived from these base units are called the derived units. So these all comes under the category of derived units. Let us see other properties of the matter. Mass and weight. So we all know that what is the mass and weight here. Let us see what is mass here. Mass means it's the quantity of the matter. Quantity of matter present in a substance is called as its mass. And units of SI units of mass is kg, kilogram. Usually we take the kilogram, it is SI unit, but usually we use the smaller units also. 1 kg is equals to 1000 grams. Usually we use the grams, but grams are not the SI units. Then what is the weight? Weight is nothing but it is the gravitational force exerted on a substance is called the weight. So when place changes, gravitational force also changes, automatically weight of the substance also changes. But basically here, in case of the chemistry, since the gravitational force is negligible on the molecules, because molecules are very small in size, that is the reason why for molecules, molecular mass, molecular weight both gives the same values. We can consider the mass as the weight only for the calculation of the molecular masses. So weight is the variable and mass is not a variable. Let us take the volume. As we discussed, volume units are length cube, that means meter cube. Apart from these are SI units, apart from these units, volume is also measured in the other units, that is 1 liter. Liter is equals to 1000 ml. You should remember that 1 ml is equals to 1 cubic centimeter. So we can write down that 1 liter is equals to 10 cube centimeter cubes. Then let us see what is meter. 1 meter equals to 10 power 2 centimeters. If you want to calculate 1 meter cube, then it will be equals to 10 power 6 centimeter cube. Then 1 centimeter cube is equals to 10 power minus 6 meter cube. Now substitute this value here. Then you will get 1 liter is equals to 10 power 3 into, in the place of cubic centimeters, we can substitute this one, 10 power minus 6 meter cube. So 1 liter is equals to 10 power minus 3 meter cube. Or else you can write down 1 meter cube is equals to 10 power 3 liters, means 1000 liters. And 1 liter is also called as the 1 dm cube, decimeter cube. So usually there is a different type of the measurements used to measure the volume. Let us see now density. Density is nothing but it is the mass per unit volume. Mass of this substance present in a particular unit volume is called the density. So let us take the two substances A and B. Imagine this is the volume I am taking. This is A, this is B, this is C. So volume equals to A into B into C. I am considering it as A equals to B equals to C. So 1 centimeter, 1 centimeter, 1 centimeter I am considering. So total is equals to 1 cubic centimeter. Now let us take two substances A and B. In case of the A, imagine 10 grams of A can be placed within this 1 cubic centimeter. Then density of this A is equals to 10 grams per cubic centimeter. And if you are able to keep 20 grams of B within the same volume, then its density is equals to 20 grams per cubic centimeter. Means within the same volume, when you are able to keep the more mass, then automatically density of the substance is also more. So higher the mass within the same volume, more shall be the density. Then what are the units of density? Already we discussed density is equals to mass upon volume. So mass means kg, volume means meter cube. These are the SI units of the density. Now let us see the temperature. So temperature is measured in various units. They are Kelvin, degree Fahrenheit and degree centigrade. In this Kelvin only the SI unit. Degree Fahrenheit and degree centigrade are not the SI units. Now let us see how to convert the one of the unit to the another form. Degree Fahrenheit is equals to 9 by 5 degree centigrade plus 32. So when degree centigrade is given, you can convert it to the degree Fahrenheit. When degree Fahrenheit is given, you can convert into the degree centigrade. Similarly, Kelvin is equals to degree centigrade plus 273.15. So these can be converted in this format. So let us take an example here. Human body temperature. We know that it is 37 degrees centigrade in degree centigrade. But in degree Fahrenheit, this is almost equals to 98.6 degree Fahrenheit. So in case of the kelvins, it is nearly equals to 310 kelvins. Means only numbers changes because as we are changing the measuring units, numbers also changes. So this is about the properties and measurements of the matter. And if you have any doubts, you can write down us to the classroompoint@gmail.com without giving any gap while typing the classroom point. Continuously how to type it, classroompoint@gmail.com. Please do mention your name and do not share any of your contact numbers or contact information. Only name and your doubt, so that we can discuss in another video of all the persons who are giving the doubt, who are writing the doubts. All the doubts shall be discussed in a single video. Subscribe the channel. Thank you.